Hi, this is a short video on single frequency analysis of multisim for AC circuits, and I would like to go over the simulation for SFA very quickly to show you some of the tips and tricks that we can use for this kind of simulation. First of all, I have drawn a circuit, a series RC circuit. It can be any circuit, parallels, series RL or RC circuit. As you can see, this has a source frequency of 60 Hertz, and we have the voltage source value and two components, resistor and capacitor. What I like to mention for showing the node numbers here is that you can go from options and sheet properties, and from sheet properties net names, and click on show all. So it will show you all the node numbers on the circuit, so we can use it in the analysis. From simulate, go to analysis, and from analysis go to single frequency AC analysis. So you will be able to use any combination of the voltages and currents in the circuit, so you can basically show all the current, voltage, and impedances in the circuit. So as you can see, there is a list of current and voltages of the circuit that you can use, add or remove, so you can see anything that you want. For example, as you can see, this is a series circuit, so the current for all the components are the same, IC1, IV1, and also the PC1, PR1, and V1. As you can see, everything is shown here. But you can add expression, so this is a very convenient tool in order to calculate the impedance of a capacitor. For example, use add expression, and then you can use the voltage across capacitor divided by its current, and it will give you XC, which is the impedance of the capacitor. For example, here I have used, as you can see here, I have used V2, this expression. Look, V2 over IC1. V2 is the voltage of node 2, and the other part, the other terminal of the capacitor is grounded, so I can use just V2 divided by IC1, so it will give me XC of the circuit. Or I can use the voltage source divided by the circuit current or its current, like this one. I have V1 over V1 is the voltage source divided by I of V1, which is the current of V1. So it will give me the Z total, right? The total impedance, because I'm dividing the voltage source by its current. So it will give me the total impedance of the circuit. So these are the things that we can use. So basically you can write, simulate IC1, IR1, and also you can use the voltage across these components divided by its current. So it will give us the impedance of that component. So basically I have done these things here. So this is on the output tab in the SFA, single frequency analysis. And so you can basically choose any voltage or current or write any expression that you want. From the frequency parameters here, the first tab, you can choose either to see real, imaginary, or magnitude phase of the simulation. So for magnitude phase, as remember, it will be a number and an angle, right? So if I choose this one and click simulate, I will have all the voltages and current, as you can see. So I have IR1, which is equal to IC1, and you can see it's 352.75 with the angle of 69 degrees, 0.3. And so everything is basically shown in magnitude and phase, which is the phasor form, right? So I have V1 over IV1, which is 2.8.3 K, and the angle is 110 degrees. Okay, so this will be the total impedance of the circuit. So all the values you can use, you can calculate in the single frequency analysis, as you can see. I would like to mention that the phase angle is sometimes the phase angle itself, or its complement, which is the difference from the angle that you calculate from 180 degrees. So make sure that this is not confusing you, because there might be a number that is the complement of 180 degrees. So it is the difference of that number to 180 degrees. So here the angle can be 110 or 70 degrees, right? Which is the complement or the difference from 180. One more important thing, please use this icon, black background and white background, so you will have a white background when you take a screenshot of your simulation. So for the SFA, as you can see, you can have magnitude and phase, and also you can go back to the simulation and choose real and imaginary. So you can from the first tab use the real imaginary. So for some labs we need phasor form, and for some of them we need real and imaginary. So if you simulate with real and imaginary, everything that you had will be in the real part and imaginary part. So this way you can calculate total impedance, impedance of a capacitor or an inductor, or current and voltages in the circuit. That's pretty much the short video on SFA. Please use white background for your screenshots, and let me know if you have any question. Thanks.